Hey everyone, it's Joe again. I'm going to bring a little bit of attention to the last problem that we were working on. Basically, we did a nodal analysis. Another way we can do this is by finding an equivalent resistance and finding what the current source is. Basically, we can do this by using a Wye Delta transform, or as we can do is a Y to Delta transform or a Delta to Y transform. So let's get started. Basically, for a Y to delta, you'll have a configuration that looks something like this. If you have a Y, it literally looks like a Y. It is said to be balanced if R1 is equal to R2, which is equal to R3. Now, if you're doing a transform from Y to delta and R1 does equal R2, which also equals R3, then basically we have a balanced network. So basically RY is just R delta divided by 3. Or R delta is equal to 3RY. However, if they are not balanced, there is a different equation for that, and RA would actually be equal to R1, R2 plus R1, R3 plus R3, R2, and then you want to divide it by the resistance that it's across. So for example, RA, I always associate A with 1, B with 2, and C with 3. So in RA's case, it would be R1. Or in RB's case, you would divide by R2. In RC's case, you would actually divide by R3. And the numerator is going to be the same on all of these here. So we can just copy this. Oops. We can just copy this part here. Oh, I guess it just wants to get the RB in there. Oh, we'll let it. So we'll just paste that over here, and this goes up here, and just delete this and this. And then we can say the RC is basically the same thing. Just paste that up here. Make it smaller. Boom. This one is RC. Is equal to this. And you just divide that by R3. And the same concept will probably go for delta to Y, and I'll show you here in a second. Alright, so again, it is said to be balanced if all R1, R2, R3 equal, or RC, RB, and RA are equal. If that's the case, then just use these equations. There's no need to use the other equations. So for R1, R2, and R3, we have similar equations. Basically, instead of the denominator being the one that changes, it's going to be the numerator that changes, and the denominator will stay the same. So in all of them, it's actually going to be RA plus RB plus RC. Again, RA plus RB plus RC. And RA plus RB plus RC in the denominator. But the numerator is the one that changes. So for example, I was telling you that I associate A with 1, B with 2, and C with 3. So what you're going to do is multiply the top one. So in this case, we're trying to find R1. So I try to leave RA out of the equation. So it's R2, R3. This one we're finding R2. So we're going to leave, I associate 2 with B. So I'm going to leave RB out of the equation. Let me fix this one. At R1, we leave RA out of the equation. So it's RB, RC. R2, we leave RB out of the equation. So it's RA, RC. R3, I associate 3 with C, so you do R1, RA, RB in the equation, and leave RC out of it. Alright, so basically we have the problem that we were working on last time. It looks something like this. Here are the equations on the left, and here's the circuit, and now we have to identify what the Y's and the deltas look like. Okay, so the first thing we're going to do is identify which one the Y's, what are the possible Y's. And as you can see in the two images I provided, there are two. There's one that goes across the 12.5 and 15 ohm resistor and across the 5 ohm resistor, and you can tell it kind of makes a Y shape. Or the opposite is true, where it goes across the 10, 20, and the 5, where it will make a Y in this direction. Now, what about our deltas? So the deltas, there's 3 possibilities, and you can kind of tell that this node shares this node, so it will actually come together like this. And or this node actually shares this node, so that's the point, and it looks like that. Or we know that this node right here and then these 2 nodes share the same, so basically it looks something like that. Alright, well, it doesn't matter which one you do. Honestly, any one that you choose to do is going to simplify the circuit dramatically. So let's just go ahead and choose a Wye Delta. It's the second one that we found in the Y conversion. So we'll do this one. So if we change it, basically it looks something like this. If you have a Y configuration, that's a resistance and that's a resistance. And let's say that basically we have A, B, and C. This resistance right here would be the RC resistance. The resistance here for the delta would be an RA, and the resistance here would be the RB. Now the way that I think about it is if a B is on the opposite side of RB, or C is on the opposite side of RC, or A is on the opposite side of RA. And then with RC, I just say R1, R2, and R3. And that's basically, I just make an ABC triangle. So A, B, and C, and then C is across from RC is across from C, B is across from B, and RA is across from RA. And then I always pick RC between A and B, and then I know that's R1 and R2, because I associate, like I said, A with 1, B with 2, and C with 3. So basically, we start off with this circuit, and if we were to do the transform without doing any numbers, plugging in any numbers, in general, it's going to look like this. So basically, in order to find what RB and RA and RC equals, we have to use the equations on the left that we already have. And RA is going to be equal to R1 times R2. So we got 10 times R2 is 20. So in this case, I already labeled this is R1, here's R2, and this one is R3. So R1 is 10 ohms, R2 is 20, and R3 is 5 ohms. So then plus R1, R3, which is 10 times, and like I said, R3 is 5, plus R2, excuse me, R2, R3. So we have 20 times 5. And we're just going to divide that by R1, which is 10 ohms. So if we do that, it's going to come out to, if you put that all in your calculator, basically we should get RA equal to 35 ohms. Oops, not 30, 35. And then the same for RB. We got R1, R2, so it's just 10 times 20 plus, and it's just going to be the same thing, 10 times 5 plus 20 times 5. And then we're going to divide that. Instead of dividing it by R1, we're actually going to divide it by R2. So R2 is going to be 20. And this one will give us a total of RB, which is 17.5 ohms. And then the last one, exactly the same, 10 times 20 plus 10 times 5 plus 20 times 5 over, and then since we're doing RC, we need to do over R3, which we found to be 5 ohms. And this will come out to a total of RC of 70 ohms. Make sure to remember units. Alright, so if we go down, and yep, that's exactly what we got here, we can now simplify the circuit. So basically 30 is going to be in parallel with 70. And if you do 30 in parallel with 70, you get 30 times 70 over 30 plus 70, which is 100. and you should get 21 ohms. So now you have a circuit that looks like this. It's 21, and then you have this, and this, and this, and then you're going to have these two. So basically, the 21 ohms, the way that I look at it is there's a node that's going to be right here that's shared, and this node is shared between this and this. And there's a node right here and right here that's shared between that resistor and that resistor. So that means that, let's call this 1, 2, 3, and 4. So 1 and 2 is in parallel. So basically that means that 12.5 is in parallel with 17.5. And we know that 15 is in parallel with 35. So if you do 70 in parallel 30, we get 21. If we do, which is that one, if we do 12.5 in parallel with 17.5, that comes out to 7.292. So 12.5 parallel 17.5 is equal to 7.292. And 15 in parallel with 35 is going to give us 10.5. So now redrawing the circuit, we have a 21 ohm resistor, we have another resistor here, and another resistor here, and those should go together. Basically the first one is 7.292, and this one should be 10.5. And then after that we just have some sort of voltage source, 120 volts. So now we know these two right here are in series. So basically this should be 17.792. Which will be in parallel with 21. So if you do 17.792, let's just do that in the calculator, 17.792, and we multiply that by 21, and then we divide that by 17.92 plus 21. We get an answer of 9.63168, and I believe, if I remember correctly in the last video, that's what we got when we did voltage source over the current source. We get the R equivalent, so that equals to 9.632. 9.63168, so about 9.632. Now, since we know the R equivalent is this, and we want to find the current source, so basically we're trying to find current here, current source, we know that current is equal to your voltage source over R equivalent. So basically you're going to get 120 divided by 9.632 is equal to IS. So IS is equal to 120 divided by answer 12.458. So 12.46 amps. And I do declare that's what we got before. If we look on, oops, wrong LT spice. If we look at our LT spice and we look at the current going across here, we got 12.46. So looking back at what we got on our answer, we got 12.46. So it matches. It's exactly right. Alright guys, that's how you do Wye Delta transforms. If you have any questions, please let me know in the comments. Thank you.